Hello everyone, I am Vince Sanchez Amarilla, your math teacher in this session. For today's video we have to tackle two different topics, which is to illustrate the subsets of a line and to classify the different kinds of angles. First is we have to illustrate the subsets of a line. In geometry, a line is a perfectly straight one-dimensional figure extending infinitely in both directions. There are two subsets or subcategories of line in geometry. The subsets of a line has two subcategories, which is the line segments and rays. We will tackle these two subcategories a little bit later. Since we are going to illustrate the subsets of a line, first is we have to define what is line. In geometry, a line is an infinitely long object with no width, depth, or curvature. It is made of a set of points which is extended in opposite directions infinitely. A line is a one-dimensional figure. According to the text, a line is a one-dimensional figure, so it has no width, depth, or curvature. In order to form a line, we have to connect 2 points or a set of points in order to make a line. For example, this one, we have point 1 and point 2. We have to connect these 2 points in order to make a line. These two arrowheads here, arrow 1 and arrow 2, symbolizes as infinity. That is why the set of points, which is point 1 and point 2, is extended in opposite directions infinitely. This one, left side and to the right side. And now we can name a line by simply having a small character or small letter. For example, we name this line as line H. That one. This is line H. And we can write it as line, this one, line H, or this one, having this symbol H that has line and arrowheads above. That is line H. Another example, if we have this line here, we will name this as line G. We can write it as line G, or simply having this symbol, line G. Okay. For example, if we have two points in a line, let's say for example, this line H has 2 points. This point 1 is point A, and this one is point B. Okay. We can name this line as line AB, or this one, line AB, or line BA. Or by having this symbol, line AB, having this line with the arrowheads, or line BA, this one. Another example, we have this line XY, or Also, we can have this line YZ. And this is line. And now let us proceed to the two subcategories of the subset of a line. First is we have the line segment. Line segment is a section of a line bounded by 2 points or 2 connecting endpoints. Say for example, this one. Line that has point A and B. Okay. A line segment may be called as line segment AB or line segment BA. Or we can also write it as line segment AB or line segment BA. This one. By having this symbol, which is line. If we are talking about line, we can have the symbol, this one. But if we are talking about line segment, we can have this symbol, which is only line. Okay. Another example in line segment. If we have dot point C, point D, and point E. Okay. We can name the line segment CB. CD rather, or line segment DE. Or we can also name this as line CE. This one. From here, C to E. This one. Line segment CD, line segment DE, and this one, line segment CE. Another example, if we have line segment F, G, and H. In here, we can have line segment FG, line segment GH, and line segment FH, or vice versa. If we have line segment FG, we can also have line segment GF, or if we have line segment GH, we can also have line segment HG, or if we have line segment FH, we can also have line segment HF. Okay, now let us proceed to our next topic. This is under the topic line segment. Line segment has also a what we call as congruent segment. What is congruent segment? A congruent segment is a set of two line segments having the same measure or equal in length. Let's say for example, Okay. Let's say, for example, if we have this set of points, let's say, for example, this is point C, D, E, F, and G. Okay. According to the text, congruent segment is a set of two line segments having the same measure or equal in length. Let's say, for example, this line segment CD. As you can see here, the same measure of line segment CD is what segment? Line segment EF. Okay. Line segment CD is congruent to line segment EF. This one. Another one. Let's say, for example, this line segment CE. What line segment is the same with the length of the line segment CE? We have line segment DF. Since it has 1, 2, 3, 4 lines in between, and this one, the line segment DF, it has 1, 2, 3, 4 lines, 4 lines in between. So they are congruent segments. Line segment CE is congruent to line segment DF. This one. In this example, the only congruent segment here is the line segment CD, which is CD, and the line segment EF. They are congruent since they have two lines in between, 1, 2, and this one, 1, 2. Also, the congruent segment CE and DF, which is they have the same lines in between, which is 1, 2, 3, 4, and this one, 1, 2, 3, 4. Okay. And since we are done with the line segment and the congruent segment, we have to proceed to rays. This is the second subcategory of segments of a line. Ray is another part of a line. It is a combination of a line and a line segment that has an infinitely extending end and one terminating end. Since ray has a combination of line and a line segment that has an infinitely extending end and one terminating end. For example, we have the endpoint D, or the terminating point D. To find the ray is we have to move from here to here, from this point D to right side. So we have ray DE, or we can also write this as ray DE. Also, we have ray DF, from D to F. Also have ray DF. And if we have this endpoint E, we can have ray E from this one to right side, ray EF. And if we have endpoint E, we can also have this point here to the left side, which is ray ED. Since a ray is a combination of a line and a line segment that has an infinitely extending end and one terminating end. This one is the terminating end and the extending end is the F and D. And for the third one, if we have this endpoint or the terminating end, which is the point F, we have FE. We have ray FE, ray FE, and if we have the endpoint F, we can also have ray FD. Okay, and this is the two subcategories of our subset of a line. First is we have the line segment, and the second one is we have rays. And now let us proceed to our next topic, our second topic, which is to classify the different kinds of angles. First is we have to define the word angle. An angle is a figure which is formed when two straight lines or rays meet at a common endpoint. The common endpoint of contact is called the vertex of an angle. Let's say, for example, if we have this angle and we have A, from point A to point B to point C, and according to the text, the common point of contact is called the vertex of an angle. Since the point B is the common point of contact, this is the vertex. This is the vertex. And angle is denoted by the symbol, this one. And now we have angle ABC. And also we have angle CBA, this one. This is an angle. Another example, if we have this kind of angle, this one, X, Y, and Z, we can write it as angle ZYX or angle XYZ. And this is angle. And now let us proceed to the different kinds of angles. There are three different kinds of angles. First one is acute angle. Acute angle is an angle measures less than 90 degrees at the vertex. This time, we have to measure an angle using a protractor. An acute angle is an angle measures less than 90 degrees at the vertex. So, an acute angle is, since we have this one, this is 90 degrees. Since this is 90, from here to here, 90, and from here to here is 90. This is 0, this is 0. From here, 0 to here is 90. And an acute angle is measures less than 90 degrees. So, an acute angle is like this. It is measured less than 90 degrees. Say for example, this angle or this acute angle has 45 degrees. Another, this angle for example, this angle has 60 degrees. Another example, this one, this angle, let's say this angle measures 25 degrees. So this is an acute angle. And now let us proceed to the next angle, which is the right angle. A right angle precisely measures 90 degrees at the vertex. This kind of angle is very simple because it only measures 90 degrees at the vertex. Nothing more, nothing less. Since this is 90 degrees here, from 0 to here is 90, and from 0 to here is 90. This is 90 degrees, and also this is 90 degrees. And this angle is an L shape. Since this angle has 90 degrees, this is called as right angle. And now let us proceed to our third and final kind of angle, which is the obtuse angle. Obtuse angle is an angle which is greater than 90 degrees but less than 180 degrees. Since this is 0, and from here we have from here to here we have 90, and 90 above is obtuse angle. Let's say for example this one. Since this angle is more than or greater than 90, and this angle is greater than 90, it is an obtuse angle. Let's say for example this angle has 110 degrees. So it is an obtuse angle. From here to here, this one. Say for example, if we have this angle, this one, since our right angle is only here, which is formed as L, letter L, and this angle here is formed more wide than the right angle. This is called as an obtuse angle. Let's say for example this is the right angle, and since this kind of angle is greater than 90, this is an obtuse angle. Since this angle has 135 degrees, so it is an obtuse angle. Another example, this one. Since this is too wide than the right angle, which is formed as letter L, and this one is too wide, this is called as an obtuse angle, since it is greater than 90 but less than 180. And this is the end of our topic for today's video. I hope that you learned a lot from my video tutorial. Once again, this is your math teacher, Vince Sanchez Amarilla. Thank you and God bless. Bye-bye.